We have a question here that looks a little bit scary, but I think we can work through it. So when we have an equation like this where we have denominators, remember our strategy is to always multiply both sides of the equation by the common denominator. Right? And what that does is it eliminates fractions. It makes the fractions disappear. All right, so in this case, we have 12 minus 25 over x equals 4 plus 7 over x. All right, so if we look at our denominators here, we have a denominator of x and we have a denominator of x. So hopefully we realize really simply here that the denominator, the common denominator of those two is just x. So I'm going to multiply this side by x, and I'm going to multiply this side by x. So x times 12 is 12x, and then x times 25 over x, just to make sure everyone's clear with that little step, I have a minus 25 over x in fact. When I have x times 25 divided by x, the x cancels out. And that's what I wanted it to do, right? I wanted that fraction to go away, and now it's going to go away and leave me with simply negative 25. Likewise, on the other side, I'm going to multiply this x times the 4 and the x times the 7 over x. So x times 4 is 4x. And then 7 over x times x, the x's cancel again, and we're left with 7. Now we have something that's a very simple linear equation in one variable. So now we do the algebra we've always done and we're comfortable with. We rebalance everything on opposing sides. And so we get that those cancel, and 12 minus 4x is 8x. And over here we have 32. We divide both sides by 8. And we get x equals 4. Now remember, in these questions, the only thing we need to do is check the answer. When you have x appearing in a denominator, you need to go back and check to make sure that this value of x doesn't cause problems. And we can quickly see that there is no problem if the denominator is 4 here. All right, if the x answer we received for this question was 0, then we would have a problem and we would say there is no solution. But in this case, x equals 4 does not present a problem here.